Hello friends, myself Chetan Sonar, and today we are going to see what are the solid principles. Solid is a word acronym for 5 design principles available for object-oriented designs. Okay, so using solid principles, we can make our object-oriented code more understandable, maintainable, and flexible. So that in future, if any new requirements comes into our application, then we can write it in a more efficient way. Solid principles are not specific to any programming languages. They are independent of the languages, so they are basically designed for the object-oriented design, object-oriented programming languages. You can have Java, Python, C Sharp, or any other language which follows the object-oriented rules. So let's start with the solid principles. So what does solid principles? In year 2000, Robert C. Martin introduced 5 design principles so that we can make our object-oriented designs more understandable, flexible, and maintainable. And in future, if any changes come into our application, so that we can write those in more efficient ways. Now let's see what are the 5 design principles available in Solid. So each letter in Solid word represents a single principle. So S stands for single responsibility principle, O for open close principle, L for Liskov substitution principle, I for interface segregation, and D for dependency inversion principle. So what single responsibility principle says? Single responsibility principle says that every class or module should have only one reason to change. This means that every class or similar structure should have only one job to do. Our class should not be like which does all the operations itself. So it should not be like a Swiss knife where if any one change is required, so we need to change the entire tool itself, like a Swiss knife, where if any one change tool is faulty, then we need to change the entire Swiss knife itself. We need to repair the entire Swiss knife. So our class structure should not be like this. So let's say we are writing an application where we want to do some operations related to workflow. There we have mainly three operations: perform DB operations, generate some files, and send email. So these are the main three operations which you want to do, but these are independent of each other. So we are writing an application like this, okay, where we are writing a program like this, where we have a create workflow function and we have some input parameters into it. And we are first we are doing the scale operation, database related operation, then we have file related operation, and the third one is the email operation. Okay, it's something like which we are doing, assigning all the tasks to one single person. So we should not do like this in the SRP. This is violating the SRP principle. So how do we solve it? So let's start. We should assign three different tasks to three different persons. The first person should handle the database related operation. The other person will handle other person or class, we can say, will handle the file related operations, and the third class will handle the email related operations. So how do we write that into the actual program? So we'll create a DB related class where we are just passing the input parameters and it will run the SQL query. Then we are writing the file handler related class where we are handling all the file operations which we are in that we are writing the text to the file. Then there is the email related operation. So in email class, we are doing the email handlings, of which we are sending the mail to the approver that this particular workflow is assigned to you. And the main class will contain all this implementation. It will create object of all these three classes, and it will call the respective methods. But that doesn't mean that each class should have only one method. Those classes should have the related methods. So if I'm saying that DB operation class should have the DB related operations, so that means it can have multiple methods, but all those methods are only responsible for the database handling, not for email handling or the file handling. Similar way, file handler also can have multiple methods, but all those methods are related to the file handling related thing only. And email class will handle all the email related functionalities. Let's start with the open close principle. So what open close principle says is that our software module or class should be open for extension and closed for modification. So what does that mean? So whenever a new requirement comes in, our class or module should be introduced. If for any new requirements, we should implement new classes and new modules or interfaces or similar structures. And close for modification says we have already developed a classes. Whatever the already developed classes are there or structures are there, those are already unit tested thoroughly. So we should not alter that unless we found any bug into those. So we should always include new classes whenever the new requirement comes in. And if there is any existing bug comes in, then only we should change the existing classes. So let's see how that will work, how we are violating the open clause principle, and then we will try to solve it. So let's say we are developing a gaming application where we have a warrior handler class, and we have the attack method and a string field which is saying the warrior type. So here I am saying that warrior, if I have two players, here here I have two players, sword warrior and pistol gun warrior. So whenever I am saying that a sword warrior come in and we are executing the attack method of sword warrior, here it checks that if the warrior type is of sword warrior, then do this operation. If the warrior type is with a gun, then do this operation. Let's say now few more warriors are introduced in our gaming application. So let's say we have introduced a warrior with a battle tank. So here we will add one more if condition in the existing class. And then if what else if there are one more player is introduced, then we are adding one more if condition. So this is where we are changing the existing class. So this is basically violating our open class principle. So how we will solve it? So we will introduce an interface. Let's say I'm introducing an interface I warrior. Into that I'm writing a basic void method, that void attack. This is an abstract method. Then I'm implementing this I warrior interface into the sword warrior. And Archer will also implement the iWarrior and implements the attack method. Then our main class, warrior handler, should have a method, let's say with the fight, and the input parameter as the iWarrior interface type. And then we'll execute the attack method on that specific object. So that this is how we should ideally implement our class structure. So if any new player comes in, then we will implement the new classes. Now let's start with the Liskov substitution rules. So what does the LSP says? LSP states that you should be able to use any derived class instead of a parent class and have it behave in the same manner without any modification. So what does it mean? It ensures that a derived class does not affect the behavior of the parent class. Whatever the behavior the parent class have, all the methods which the parent class or base class have, that should be same and it should not affect the behavior of that. In other words, a derived class must be substitute for its base class. So whenever we say we are using a base class, then we should always able to provide a child class as a substitute for the base class. So let's see that into the example. Let's say we have an SQL file class where we have two methods, load text and save text, and two fields, file path and file text. Okay. Now we have asked our we have asked to develop an application where we are just saving the data for the application. Okay, where we are saving the multiple files and some maybe some showing the data also. So we have written a method like this, that we have uh, list of SQL files where we are passing that SQL file as a uh, type. Now here we have a get text from files method where we are getting the data from the file and we are just returning it back. And here we have one more method which is saving the data which we are passing into the list of files. Okay. Now let's say our team lead asked us to develop there asked us that there are some files which are read only also, which cannot be accessed by ourselves. So how we will implement that? What we'll do, let's make a change. Okay. How we'll implement that? We'll just make a condition over here in the save text to files that obj is not of read only files. We'll make an if condition like this. So this is something which we are actually violating the principle of LSP. So what LSP says, in every condition, or child class should be substitute for base class. Here, what is happening if we are having a read-only files? So in that cases, we are not able to call this save text file method. So this is a actually violation of the LSP principle. So how we will solve it? So we will implement two interfaces first, iReadable SQL file and iWritable SQL files. So here we are saying in iReadable SQL file, we are writing a method, abstract method that load text. And in the interface iWritable SQL file, we have a save text method. Now we'll implement SQL file class with these two methods, iWritable SQL file and iReadable SQL file. And we are having the definition for save text and load text. Then in the main class, we are saying in the SQL file manager, get text from files that will be as it is because there will be no change whether it is readable or writable. Okay, or maybe we can say that I we should have to get the input as list of iReadable SQL file. Maybe those file are not readable. Okay, so in that case, we will take the input parameters list of iReadable SQL files and we'll just return the text. And for the save text into files, that we are taking the iWritable interface as a type, input type, list of iWritable SQL files. In this case, now in every case, we will be able to do this. So if the we are implementing the iWritable SQL file, then only we have this kind of thing. So it will not throw any exception over here, or we don't need to write any if condition kind of thing. Now we will see what is interface segregation principle. So what ISP states that clients should not be forced to implement interfaces they don't use. So what does that mean actually? So instead of one fat interface, many small interfaces are preferred based on the group of methods, each serving one submodule. So instead of writing a very complex and very big interface, fat interface, we should write small interfaces with specific functionalities. So let's see that into that example. Let's try. Let's maybe we are developing an application where we are having multiple team lead, manager, developer, or programmer. We can say uh, are the roles over there. Okay. So how we will do? We have let's say we have a iLead interface where there are create subtask, assign task, and work on task. These three abstract methods are present. Now, if I write an team lead class with implementing iLead interface, then I'm saying code to assign in I will implement assign task method and create subtask method and work on task method. Now, when I try to write the manager class, he can assign the task and create subtasks, but he cannot work on the task. So this method is actually the third method is work on task is useless, and it is throwing an exception that this method is not implemented or we cannot manager can't work on task. So here we are unnecessarily forcing manager class to implement a work on task method which should not be there. So how we will solve this? So first we'll implement two interfaces. That first one is iProgrammer, which have only one method that work on task, and the second interface, iLead, where we are saying there are two methods, assign task and create task. Now let's write an lead team lead class again. Team lead class will implement two interfaces, iProgrammer and iLead, because he can assign task, create task, and work on task also. So he will be implementing all these three methods. Now we will write a manager class. So he will only implement the iLead interface, not the iProgrammer interface. So he needs to implement only assign task and create subtask method. And we'll have a programmer class where he is only implementing the iProgrammer interface and he implements the work on task method.